Welcome to this small demonstration video of SystemairCAD. My name is Ulf Bang, and today I'm going to tell you a bit about the functionality we implemented for ISO 16890. You can find the new dialog by clicking the toolbar bottom up here in the top of the user interface, but you can also access the functionality directly from the filter dialog. But what is this ISO 16890? ISO 16890 replaces the old EN 779. EN 779 was only based on an average particle size of 0.4 micrometers, and the new ISO 16890 is based on 3 particle size fractions. We have EPM1, EPM 2.5, and EPM 10. It requires a minimum filtration efficiency of 50% to be classified within these 3 categories. And there is actually also a 4th category. If the filter is less than 50% efficient of PM10 particles, then it will be classified as a coarse filter. So we end up with 30 filter classes divided over the 3 particle sizes, EPM1, EPM 2.5 and EPM 10, in steps of 5% in efficiency. And then we of course have coarse filters. The standard can also recommend what total filter efficiency you need for your system depending on the outdoor environment and the application. In this table, it classifies the outdoor environment in 3 classes: Odor 1, Odor 2, and Odor 3. Odor 1 is countryside, and Odor 3 is mid-city. The applications is divided in supply air classes from sub 1 to sub 5. It also has a classification as general ventilation or industrial ventilation. So if we have general ventilation and we have rooms for permanent occupation, it will be a sub 2. If we have rooms without occupation, a garage room, data centers, underground car parks or alike, then we have a sub 5. If we on the other hand has hospital with hygienic demands, then it is a sub 1. There's also a reference table where you can see that a specific outdoor air class and the application, then you can see what the recommended filtration efficiency should be in your ventilation system. Let's take an example. We have outdoor air 3. We are in the city at a hospital, so we have high hygienic demands, so it's a sub 1. And if we check the reference table, then we can see that Odor 3 sub 1 will require an EPM 1 90% filtration. If I look in my SystemairCAD, I can see that I actually only have a EPM 1 85% as the highest efficiency for EP1 particles. And here I need to combine filters in more than one filter stage. How do I do that? I'm aiming to have a total filtration of EPM1 90%. But even though a filter is EPM 10 70%, then it still filtrates some of the PM1 particles. And in this case, you can see that we actually have an efficiency of 25% for PM1 particles, even though it's a PM10 filter. If we calculate the total efficiency from this formula and we select a filter combination of an EPM 10 70% and EPM1 85%, then we will see that we actually get a total filtration efficiency of 90.25%. And that is of course sufficient when our requirement was 90%. Let's look at SystemairCAD and do the very same example. This is a basic Geniox 14, and let's start by putting in a panel filter M6 or EPM 10 70%. Okay, our main filter should be a EPM 1 85%. Okay, so now I have a stage 1 and a stage 2 filter. So let's check what our ISO 16890 calculation says. So I start by putting in that it is an industrial application that I'm looking for. I have a sub 1 environment and an ODA 3 outdoor environment. So that means that my minimum recommended filter efficiency should be 90% as we calculated in the presentation. We have a filter stage 1 of EPM 10 70%, a filter stage 2 EPM 1 85% that we selected in the unit. The system automatically recognizes the right filters, and the total calculated filter efficiency is EPM 1 90.25%. That means above the 90, so we actually meet our target. If we look at the printout, then we introduce the value on the front page. If we zoom in a bit, then we can see that filter ISO 16890 is here as the first value on the filter, 90.25. Supplier filter is EPM 10 70% plus a EPM 1 85%, and the extract is an EPM 10 60%. This concludes the small video about ISO 16890, and I wish you a good day.